Welcome back, algebrists. Today we're going to jump in. We are going to finish the very last of this section. And there's only two big ideas that we have left. Okay, so we only have two more little pieces to knock out here. Now, first and foremost, I want to try to summarize what we just saw on the bell ringer. So in our notes, we'll just go ahead. Last thing that we did was solutions to these guys, and there we left off. Okay, so immediately following that solutions example in your notes, we're going to make an star, or a star rather, and we're going to make an important statement. Really important that everybody has this down. We are going to use this throughout this year, next year, like you're going to see this again multiple times. Okay, we're going to make the following claim. Given a quadratic, and really we're just going to say given a polynomial. It doesn't have to be a quadratic. Those are the type that we happen to be focusing on right now. Given a polynomial, x equals a is a solution. And I'm not going to write all of them, but instead of solution, what are some of the other words that I could say? Let's see. We're going to get random numbers here. We have 26 of us, which can't remember the last time that everybody was in class. So good on you guys. I don't know where my comma is on this calculator. All right, Naomi. Instead of solution, what could I say? A root. It could be a solution or a root. Lily, we made brief eye contact there. Solution, root. So that's an okay answer, but I can hear you turning your pages. If I scroll down here, a solution, a root, a zero, and this is going to be a freebie for number 16, whoever that is. I don't know who's 16. I don't have my sheet in front of me. Intercept. X-intercept specifically. Okay, we have a last little piece that might sneak in with those if we wanted to. But given a polynomial, x equals a is a solution. And if I write this, somebody who's not in my geometry class right now, if, can you guys tell me what it means? One more time? Okay, so very common in geometry. If you want to write IFF, I'm cool with it, and I will here. This is not just a me shorthand, this is everybody. This means if and only if. So it just means that if I have some statement that says if A then B, this goes the other way also, if B then A, if and only if. Okay, given some polynomial, which quadratics are, if x equals A is a solution, that's true if and only if x minus A is a factor. Now, the overlap is insane because right now in pre-calc, we're doing the exact same stuff, but a little bit bumped up, but the exact same concept shows up coincidentally at the exact same time in the year, which is kind of awesome. Okay, we are going to use this and this idea to help us find quadratic functions a little bit more. So using this idea, let's go ahead and we're going to give ourselves another little section. So we're not just solving them anymore. We are going to talk about the factored form of a quadratic. Factored form. And I will write of quadratics, but realistically this could be for a variety of different polynomials. It could be something x squared, it could be x cubed, x to the 7th, doesn't matter. Factored form is going to be the same. Okay. While we're getting stuff jotted down, first of all, when we factor, not like grouping and those types of answers, but what are we actually doing? Julia, we made eye contact. What does it mean to factor something? So other direction. So maybe, depending on how we talk about it, we're breaking it down and we're expanding it into all of its little pieces, right? And what do we do with those little pieces? How do we know we're right? And that can be a hard question, just as a little guidance. Like I think the number 26 factors as 2 times 13, and I can't go any further. I've broken it down to my two pieces whose product is the original. And that's the important piece. I think that you probably would have had that, but the language is clunky with it, and I get that. Breaking it down to smaller pieces that, when multiplied, produce what we're after. Okay, for the factored form of quadratics especially. Quadratics always have how many x to what power? Like, not how many of them, but x to the what power is the biggest in a quadratic? Squared, every time. So, if we want these, we're going to say, hey, f of x equals we'll say there's some number a that hopefully we can factor it out. And then we have inside x minus, and I'm trying to think of, the letters don't matter. Let's say r and x minus k. Where, very specifically, we'll say x equals r, which is what we would get if we set this equal to 0, and x equals k are roots. Okay. If I give you roots, you can find factors. If I give you factors, you can find roots. It goes both directions. Now, what I mean by this, and we're going to see, you guys did a problem, or probably saw a problem like this on the homework at least. We have some easy examples where we can see, like, let's write a nice equation, and we've done it a couple ways already. We've done it from vertex form. That one was nice and easy. We have not done it in standard form because it can be a little bit harder unless we have this. So I want us to find the function f of x with, let's say here we have x-intercepts at, and we're going to get a couple points. Let's say we have x-intercepts at 3, 0, and -3, 0. And beyond just the x-intercepts, we also get a point on the graph and a point, and let's say that this lovely point is 1, 2 on the graph. Okay. We are looking for a function that has these x-intercepts and it passes through that particular point. When we do this, it can be a challenge to find. If you guys look back through your notes, you've seen we've found quadratics. If I give you the vertex and a point, you can find it. We've done quadratics where I give you 3 points that weren't the x-intercepts, and it was that big 3x3 system of equations. That sucks. I don't really want to do that every time, and I doubt you guys do either. So here is a different approach. Right off the bat, we're going to make sense of this expression, or this phrase. So here we go. Immediately, I want to see if we can find the factors. And I'm going to ask that you guys read this statement once, twice, thrice if needed. I want you and your neighbors, I'm going to give you about 60 seconds, find me from all of this information in here the factors that I want to be able to write down. 60 seconds, chat with your neighbors, I'll come around. Don't hesitate to ask me if you have no idea, because I'll push you in the right direction. Go. I think so. I wrote it a little bit differently, but if 3, 0 is my intercept, then x equals 3 is the solution. They're the same thing. Okay. If x equals 3 is a solution, then x minus what is a factor? 3. It's the same situation as this. So right off the bat, I know that one of my factors from this, if that's x equals 3, it must be x minus 3. Can somebody tell me the other factor? Good. X minus a -3 turns into an x plus 3. Now, when I actually do these problems, and when you do them, I probably wouldn't break it up into 2 different steps here, but this is like step 1. Let's write out the factors. Everybody should be, whether it's right this second or not, we need to be able to move from x-intercept here to the factors. This is imperative. Okay, we will get more practice with it. Now, let's go one step further. Before I move on, anybody not catch what just happened? Okay, so when we, and this is part of those notes situation, so if you didn't catch the notes over the weekend, and there's more than one person that didn't, these are our 4 statements. If x equals a is a x-intercept, we could have written this as the point a comma 0. That's the change that's happening. Now, that is interchangeable with any of these. I could say it's a solution, a 0, a root. Now, from here, we are going to introduce that nice factored form, and it's here. Do we know the value of a right now? This one? Nope, no idea. So let's write it out. I don't know what it is, but f of x is equal to a. Do we know one of the, or at least both the factors, I guess? A times x minus 3 and x plus 3. All I have done is I take the factors from the x-intercepts that we were given, and I just plug it right in. If I knew the value of a, I would have an expression now. Like, I would have a full function. Unfortunately, there's an f of x, which is the same as y, and an x and an a. I have 3 unknowns in a single equation. Can't do it. Man, if only there was a point with an x and a y that I could plug in. Oh, by gosh. Check it out. Here it is. What am I going to plug in for the y or the f of x? I'm going to plug in a 2. Now, I'm going to underline that, and here it is. 2 is equal to, I still don't know a, that's a bummer. Man, what was x? When y is 2, that happens when x is 1. So I'm going to plug that in. 1, and I'm going to do a 1 here, and I'll write it so that my colors match. Minus 3 and plus 3. We now have everything needed to be able to solve for a. Take a step forward for me. I'll give you like 30 seconds. Solve this for a for me. If you don't understand, let me know because I'm going to skip a little bit of work. I think this becomes a times, and I'm not going to skip any work apparently, negative 2 in this parenthesis, and a 4 here. And you could FOIL. You're going to get the same thing, but if you can simplify the groupings first, I would do that. But I'm going to have negative 8a. Now, I rearranged it. It's a times negative 8. Can we solve for a? What do we divide both sides by to solve for a? Okay, easy mistakes to make right here. If you get negative 4, I understand completely where it came from. 100% I can see that. Unfortunately, not quite right. We're just upside down. 2/8, it's negative over negative 8. What goes into both? Oh, good. It simplifies down to 1/4, right? Okay. Now, as we look at this, did I need anything else? All I really needed was a value of a, right? So let's write our function. Here is our final answer, if we want, and I do, but we'll let you guys help me decide. F of x, we just found a was what? Negative 1/4. And then if we're already in our factored form, if I'm not told to expand it out further, I'm not going to waste the time foiling this guy back out. Now, if I asked for a solution in standard form instead, ax squared plus bx plus c, you would have to FOIL and distribute, and it gets a little bit more involved. But if you're not told to do so, I wouldn't. Cool, cool? Should we do one more like this? Okay, let's see here. I want you guys to do one for me, and again, as always, don't be shy, speak up. I will help as needed. We had only odds, right? Evens. So let's see if we can find a nice one. All right, on B, you guys get to work through the following. We have zeros, and we're told that the zeros of some function happen at x equals 0 and at x equals 1. Is there any objection to me just doing x equals 0, comma 1? Not in ordered pair. I would write it like that 90% of the time, but just to make it really clear, I'll give it here as well. You can write it the same way that I had the first time. So you have 2 zeros, and beyond that, through the point 2, negative 2. I want you guys to find me the quadratic function that satisfies these requirements. Okay, if you are comfortable with it and you get through it, feel free to check with me. We'll check the answer. Also, if your answer is good and you're comfortable with it, please feel free to talk with your neighbors as well. Not just to give answers, but to help them out. Sweet. I'll be walking around. I'm here for questions. Let's dig in. I'm going to streamline this a little bit, which just means I'm not going to do factors in this separately. I'm going to do it all in one go, and we'll start in with it. Now, I know my function is going to be f of x here in the end, and I know there's going to be an a value that we find. Now, we can jump right to this point, I think. And I'm going to use that same idea that we saw up above and just plug it in. If x equals 0 is a root or solution, what's a factor? X minus 0. I will write it here. Do we really need to write x minus 0, though? I wouldn't. What's the same as x minus 0? X. I'm okay with it, though. Can you tell me another factor knowing that this is a root? X minus 1. We have from roots to factors. All you do is x minus this, which is the same thing that we said up above. The last one, if you're getting confused and you're trying to use minus 0 and plus 0, I can see why, because we had two factors that happened to look the same number, just opposite. That was pure coincidence. All there was to it. Before we continue on, questions with this part? Because I saw a lot of faces that made me think that there might be some questions. Okay. Well, how on earth am I ever going to find the value of a? When x is 2, what is f of x? Negative 2. Well, okay. Well, I'll just let x be 2 then, and we'll go ahead and plug in negative 2 for that. And we'll go ahead minus 0 and minus 1. What do we say we're going to plug in for x? Y. Where'd you get that? Go ahead, Sonny. When Landon's back, yeah. Okay, we're literally just using this point with x and f of x. All right, can I solve this for a? I'm just going to use one color. A times, what's 2 minus 0? And 2 minus 1? Everybody agree that's just 2a? Divide by 2, I think we get a is negative 1. Once we get here, we are simply just going to plug it in. F of x is equal to negative 1 times, what's one of my two factors? X. Now you could write x minus 0. I'm just going to write the x this time. And the other one? X minus 1. If we needed to FOIL it out, we could. If you're going to pop, Sonny, you can go. You look uncomfortable. Cool. All right. For these, if you I don't think it would sound like that. If we understand the connection between roots and zeros, these problems super chill. If you don't understand it, I'm available before school, at lunch, after school. We can chat some more. All right. Last little question. We are going to look at a graph real quick. I don't want you to sketch it. I don't want you to write it down yet. We're going to try to see if we can summarize it together. We're going to look at just this one, for example. Okay, way back in chapter 1, we talked about when a function is positive or negative. And if you guys looked at the homework, you probably saw some questions like that. Do you agree? Not really do you agree. 15 seconds, super short. Talk with your neighbors, figure out where this function is positive and where it's negative. I want to see what you guys come up with because we haven't talked about this a ton. I'm going to make sure that these points are clear. 15 seconds. For which intervals is my function positive or negative? Is the question that positive everywhere clear. All right, that was about 15. Who's confident? Tell me where it's negative. Between which x values? Sure. Michaela, what do you think? Where is this function negative? Between which x values? Sure. Or positive if you'd rather. So good. If we're below the x-axis, my function's negative. I'm cool with that. Based on the numbers that we see, do you guys agree it's from negative 1/2 to 3? Everywhere in there, it's negative. Everywhere out here, from negative infinity over to negative 0.5, it was above the x-axis, so it's positive. Similarly, from 3 all the way up to infinity, it's above the x-axis, so it is positive. Does that feel okay? A function is positive if it's, a function is positive if it's above the x-axis, or if it's a positive y value. That's it. Now, as we look at these, when we start thinking about inequalities, maybe, just maybe, there's an easier way to do it. We spent a fair amount of time on linear inequality stuff. Like, not that fun to do. I don't love it either because there's a lot of shading and stuff. Maybe these will be easier. Now, the last big question. If I have a quadratic that changes from a positive number, like over here it's positive, and I'm looking at the y values, if it became negative, it must have crossed over some particular number. If a function changes from positive to negative, it must have crossed over which number very specifically? It had to have crossed over 0. You can't go from a positive to a negative or vice versa without crossing 0. Everybody agree with that? We're going to use that fact to our advantage. So, last little tiny piece, and I guess we're going to count this as its own section again, factored form we did. Last piece, and it's going to look goofy in the notes, but I'm going to move it over here because I have room. We're going to talk about quadratic inequalities. Now, they sound scary. They sound like they're going to be awful. I think they are, in my opinion, they're way easier than the linear inequalities so long as you can factor. If you struggle with factoring, you're probably going to struggle with anything quadratic, and this is something with quadratics. So, first little note, a function, a quadratic specifically, a quadratic only changes signs at, and we get 4 choices here. We can say x-intercepts. Give me another choice. Somebody who I haven't called on today. X-intercepts. What's another word that I could use, Mark? Zeros. Zeros, good. Francesca, do you have another word that we might? Roots, love it. One more. Anybody want to volunteer it? Zed. Solution. These are all synonyms. It's up to you if you want to write all four, but I'm going to stress all four. A quadratic can only change signs at these values, which means we're going to use this idea and help us to make sense of it. And we'll just jump right into an example where I annotate it. So here we go. You guys did evens and 37. So as long as I don't know 37, I'm good. Let's find, for this example, when is f of x positive? Which, is there a mathy way I can write positive? Greater than 0. Now, you could simply write the plus sign in parentheses, and that's okay. And negative. So I'm going to say f of x is less than 0, which is the negative side of this. Now, anybody love graphing and wish we went back to just graphing stuff all the time? Okay. Factoring is better than graphing? I would agree with that, but either way. Okay, so if we don't want to have to graph these, real quickly, remind me, when is the only time that my function changes signs? Maybe. That could change it. There's only very certain times when a function can change signs from being positive to negative or the other way around. Only happens where, Amy? At the x-intercepts. That is the golden key for these problems. So let's check it out. On our first function, I want to know when is it positive and when is it negative. And it's really going to be an interval, but let's see if we can make sense of it. So here we go. I want f of x, or y we can do. I'm fine with y. I want to know when is y equals 2x squared plus 12x plus 18. I want to know when is this thing positive and when is this thing negative. Now, I could have written this like an inequality instead, and we've just given the wordy version first. Well, shucks. We have two options. We can either graph it and be really precise and use a ton of points to make sure we get it perfectly, or we can forego the graph completely and just do it all with the algebra. I think we should do the second one. Okay, when can a function change signs, Natalia? Only one place that happens for us. X-intercepts. That's the roots, the zeros, right? Can we factor this? I think so, and I'm going to ask you to prove it. I'm going to call on random people, and you might not have the entire factorization. I doubt you do. Maybe you do. But let's see, Chetty, when I'm trying to factor this, because I want to find the x-intercepts, how do you start always? GCF. Is there a greatest common factor between these three? 2. Good. Okay, when I factor out a 2, Seabass, can you tell me what's left behind? 6x plus 9. Love it. This 2, I will not forget about it. It'll come along for the ride. Okay. B-dub. Now what? Okay, so we're going to look only at the pieces that I can still factor. Is that a binomial? If you're not sure, and the fact that people didn't shout it out right away makes me think maybe not. Bi means how many? How many terms are here? Not a binomial. So it's a trinomial instead. When we look at trinomials, Kennedy, we made eye contact. What's something I might try with a trinomial? Hey, look at that. It's also up on the board, but I don't know if you have glasses. On the middle board. Perfect square. Now, this one's kind of ugly. If you don't remember it, you could group it. Somebody remember how to check perfect squares? Hook it up, Hawaii. Or, just kidding, Angel. What you said squared, what do you mean?
Square and see if it's perfect.
So, you mean square root, I think. Anybody know the square root of x squared? Anybody know the square root of 9? If you multiply those, you get 3x. If you double it, do you get the 6?
Yeah.
Hey, this is perfect. I know that this factors, here's a shortcut. If you didn't watch a video, this is not going to make any sense. There's an x and a 3, and it gets squared. And what do I do with it? I add. Now, this one, kind of unique, and we're going to see why here in a second. This is my factored form of f of x. These are the same, factored form, non-factored. Now, if I wanted to, and I'm going to, but it's up to you, x plus 3 squared literally just means x plus 3 times x plus 3. And now it looks like I have two factors, which is what we should come to expect with a quadratic. There's something weird about this one that we will wind up seeing. Why did I factor it? What was the whole point of me factoring this thing? I need the roots, the x-intercepts. Now, this one's weird, and we'll do another one that doesn't happen this way. But can you guys tell me the x-intercepts, the roots, the zeros? I'm going to write roots this time. So careful. Like that change. Love that change, Angel. If you set this factor, x plus 3 equal to 0, and I'll even do it over here. I'm going to erase it in a second. We would just subtract 3 from each side. And this is me using the zero product property. And I would get negative 3. Now, this one's strange, but I think I get negative 3 again. Okay. It happened to repeat. That's it. Everybody still okay? Let me rephrase that because that's a bad way to ask it. What questions do you have for where we're at right now? Okay. I'm going to make a little note here because this is the first time it's happened for us. We have a repeated root. So it's not a flat parabola. We'll look at the picture of it here in a couple minutes. In fact, I can tell it's not. This is in, right now, this factored form because it happens to be x minus 3 squared. This looks like vertex form to me. I think the vertex is at negative 3 comma 0. And then we can see what else it does. But check it out. We have found the roots. That's like step 1. And I'm just going to put it here. 1, factor, and find roots. Okay. Now, if we don't want to have to graph everything, which I don't think that we do, I'm going to, step 2, put roots on a number line. Now, this one is unique because we only see one root, but it can happen. It just means that my vertex is on the x-axis. We're going to put the roots on a number line. Okay. I'm kind of crazy when it comes to how we write stuff down. You will see these same things happen in every class that you ever take with me in the future. I'm going to make a number line. Now, the root, or roots in this case, they happen to both be the same number. What's the only number on my number line? So I don't need a 0. What roots did we find? Negative 3. Now, if you want to put 0 on there, you can. I'm only, and I would suggest only, ever putting exactly the roots on here. Now, if this is all the real numbers, my number line, right? Negative 3, negative 2, negative 1, forever and ever, back and forth. You agree that when I put this root on there, I've split all these numbers into 2 pieces, or intervals. We have negative infinity to negative 3, there's the first half, and then we have negative 3 all the way to infinity. 2 halves of it. Now, all we have to be able to do is check the sign at any point in each interval. Question? Are you sure? Yeah. Okay. So check it out. Who haven't I called on? Freddie, give me any number in either interval. So negative 3 to infinity or negative infinity to negative 3. Give me the easiest number to possibly plug in. So negative 1, that lives over here. If we're going to go here, I'm going to check 0 because 0 is an easier number. So I'm going to check 0. And I'm going to write a 0 here. And all I'm going to do is evaluate at x equals 0 and check the sign. Now, I don't care if it's positive or negative. I do care if it's positive or negative. I'm sorry. I don't care at all about the number. I just care about the sign. We have y equals right here. We have another version of y equals right here, and another version, and another version. Any 4 of these work just as well. If we need to plug in 0 for x, I think this is the easiest one for this situation. If we plug in a 0, I get 2 times 0, it's 0. Plus 12 times 0, still 0. Plus 18. Now, I know the number is 18, but that's not what I care about. All I care about is a positive or negative. Positive. Now, it was a positive 18. I'm okay with that. I'm going to write plus right here. And this is kind of cheater notation, but just to kind of show what happened, y of 0, treating it as if it was f of x, I get 18 when I plug it in right here. Okay, it was positive there, which means if we're saying where is f positive and negative, I already know it's positive from negative 3 to infinity. Okay. Sonny, give me any number in this interval from negative infinity to negative 3.
Negative 5.
Okay. Is there an easier one you could pick? Negative 4. Now, again, I want to highlight here. These are all the same. If we are plugging in negative 4, is it as easy to plug into this original pink one here? What's 2 times negative 4 squared plus 12 times negative 4 plus 18? So you could do it. I guarantee you could do it. But I think this one might be easier. If I plug in here, and I plug in a -4, because these are all the same, they're just rewritten. If you plug in a -4 for this x, what happens to the parentheses? -4 plus 3. -1 squared? +1 now, times 2? 2. So what we just found using that form was that y of -4 was equal to a +2. Don't really care about the number, but I do care about the fact that it was what kind of 2? Positive. Now, if we look at this, and we will do another one, can you tell me where my function was positive? And I'm going to say y, or f of x in this case. I guess y, I'm going to call it f of x, it's going to bug me. F of x is greater than 0 when, now greater than 0 just means positive. Everywhere in here was a positive number, right? So -infinity, so almost. I like that thought, Angel. You're so close. I don't think I'm going to say all real numbers, though. -infinity to where? It's not going to be all reals. Because why did we put -3 on our number line? It's the root. Give me another number. So give me another word. The root, solution, x-intercept, there's one more. The 0. If that's where my function is 0, does it make sense to say my function is positive there? Is 0 positive? 0 isn't positive or negative. It splits the line, right? If this is 0, I can't include it because it wasn't when is it greater than or equal to. It was just when is it actually greater than 0. So we can only go from -infinity to -3. We have to skip over that -3. But we can pick back up as close as we want on the other side and start at -3 and go how far? Infinity. Okay. Where is it negative? Never. Now, if we look at this graph, and instead of going to Desmos, you don't have to sketch it, but I'll hopefully be able to convince you. In vertex form, which is what we happen to have here, -3, 0 was the vertex. This is my parabola. Do you agree that it looks like it's positive everywhere except right here? And that it's never below the x-axis. It's never negative. I can see it agrees with this. We can get this answer without having to go through the whole graphing process. Okay, democracy time. We do one more like this? Okay, here's the deal. We're going to work all the way up till the end of the hour, which you guys probably don't love. However, I'm not going to give you any additional homework. If you didn't do the homework over the weekend, do it, but I'm not going to give any more right now. Okay, so check it out. We're going to just destroy this problem, and I want to do one more together. All right, last one. This is example B. I want you to find for me when is the following function positive or negative. We're going to say this one is f of x equals x squared minus 5x minus 24. When is this function positive? When is this function negative is the question. I'm going to give you guys a head start on it. I will start working it in about 60 seconds. Cool. No GCF, not a binomial, but the leading coefficient is 1, which might be kind of handy. So if you're ever wondering where to start, and this is perfect. If you're ever wondering where to start, how do we start the last problem? We immediately started by doing what? Factoring. No, GCF specifically, but we have to factor it. Now, in the interest of time, I would encourage you should probably have a little bit more work than I do, but you guys will get better and better at factoring. I think, let's see, this is x minus 8, x plus 3. That is how this thing factors. I use this shortcut because I saw factors of -24 that add up to -5, and I used the shortcut. Okay, which means my roots for this problem happen at +8 and -3. Because I take each of those factors and I set it equal to 0. Again, I'm skipping over this stuff only in the interest of time. Okay. Once we have these, what do I do with those numbers? I'm going to put it on a number line. So here we are. What two numbers this time go on the number line? -3 and 8. They have to be in order. If I were you, what I would suggest is I would pick a 0 here. I'd probably pick a 9 here and a -4 here. And what you're going to find is negative, positive, positive. The middle is negative. You say why? Because if we plug in 0, Angel, 0 squared minus 0 minus 24 is negative. Now, from here, last little piece, I'm just going to write the answer, and you guys are cool to go. F of x is positive from negative infinity, to where? And? Good. And negative. Looks like it was only between -3 and 8. Okay. Tomorrow we'll debrief on this. Just so you guys are aware, planning a quiz on Wednesday over factoring stuff. Cool. All right. Finish the assignment tonight. Hopefully it's like 10 minutes, but if you didn't do anything, it'll be a bit longer. Cool. Later, Raiders.